So, um, today we are presenting the first part of our webinar series, Beyond the Lift and Shift, and we'll be covering cloud to cloud migrations. We'll be talking about things a little bit more broadly than that, but it'll be the focus and the center of the examples that we use throughout. And we'll be looking at what it looks like to migrate successfully from one cloud to another. May sound quite straightforward, but there's a few gotchas and things that we've learned from our experience that we'll share, and then we'll also look at what day two looks like. So once you've moved to the cloud or to another cloud provider, that's usually the first step. And then how do you then continue to unlock the benefits of having completed that migration? And the other thing we'll touch on as well, which is relevant to cloud, is multi-cloud. So I'll talk a little bit about that in a second. The second part of the webinar series, which we have happening next Tuesday, is AI acceleration. So we'll be looking at two angles. One is how using AI tools and technologies can help you migrate, making that faster, cheaper, and just your life easier. And then the second thing is once you're in the cloud, or if you're already in the cloud, how can you successfully deploy an AI initiative or workload, and what does that look like? So if you haven't signed up for the second part and you're interested in doing so, that's what it is. We will be following up this with an email with information on that second webinar, so keep an eye on your inbox. I think towards the end I do have a slide with a QR code that you can scan, and then you can sign up to that directly if you would like to. So before we start, let's do some introductions. I'm Technical Director at Scale Factory, and I've got my colleague Chris with me today, doing the technical part of the presentation. So I'll get him to introduce himself.
Yep, hi there. My name's Chris Musther, Principal Consultant at Scale Factory, and looking forward to sharing some of our experience in migrations with you all in the next few minutes.
Thanks, Chris. So let's have a look at the agenda and what we're covering. We'll split this into 5 parts. So the first part, I'll be talking about business drivers for cloud migrations, and some of the challenges around cloud to cloud. And then I'll hand over to Chris to cover the more technical elements. He'll be doing a bit of a deep dive, and he'll be looking at capturing requirements, building a landing zone, application platforming, observability, operations, security, and compliance, and looking at both cloud to cloud migration and multi-cloud aspects of that as well. Throughout the presentation today, we'll be using a real world example. So we're going to take a relatively recent case study of a GCP to AWS migration and using it as an example of the sort of challenges and things you can do to make your life easier in moving from one cloud to another. One other thing to mention for today, if you have any questions throughout, we've got a section at the end where we'll answer those. Feel free to use either the chat or preferably the Q&A function. You'll find them on the bar. So there's a Q&A icon. You can open that up and just put your questions in there. And when we get to the end, I'll run through those. Or you can just use the chat feature and you can ask questions as we go. So, and if you've got any questions on that, do put those into the chat. Let's get started. So, first of all, bit of a scene set. What do we mean by cloud to cloud? So, looking at 3 different scenarios with 3 different problems. The first thing is a straight up provider switch. So, moving from one cloud provider to another, say Azure to AWS, AWS to GCP. The other thing is looking at multi-cloud, which we're seeing becoming increasingly common. So maybe you run a workload on AWS and you need to run that workload on Azure as well. And there might be many reasons why you do that, which I'll go into in a second. So sort of a more multi-cloud strategy. So not necessarily moving it, but I guess replicating that workload. And then the other thing is exit readiness. So maybe cloud to cloud isn't on the cards, but for a compliance or regulatory reason, you need to demonstrate that your applications are portable enough to run on another cloud provider as part of that regulation. And maybe you need to ensure that your workload, you can demonstrate that. So exit readiness is something we'll be covering as well today. And then, as I mentioned, we'll be, as we walk through these, we'll be using a case study as an example to sort of I guess like help you kind of like visualize and sort of ground it into something a bit more real world than us just talking about the hypothetical. So, to start off with, let's have a look at cloud to cloud challenges. So, from our experience, what are some of the challenges that we see in moving a workload from one cloud provider to another? Um, the first thing is technical challenges. So you might have some level of vendor lock-in. So if you're running on one of the hyperscalers, there's a lot of highly managed services, say like AWS Lambda or App Runner. And if you're using one of those services, you're quite vendor locked in. It's very managed. It's a proprietary service, and moving your there are some tools to kind of help you along the way, but you can't just take a workload that's running on AWS Lambda and easily run it on App Runner. Compared with, say, if you're just running your applications on virtual machines, you can get, if you're running virtual machines, you've got two Linux instances on different clouds. They look and feel very similar, so you could relatively easy port your application from one to another. If you're using something like AWS Lambda, a bit trickier. So that's the first thing. The other thing is legacy debt or tech debt. So maybe the application was written 5, 10, 15, 20, 30 years ago, and some modernizations needed. So it might be running on a virtual machine. It hasn't been containerized. It's using some like legacy proprietary database software, and maybe you can move it to another cloud, but in doing so, you probably maybe you need to modernize it. You want to modernize it as part of it, or the modernization is the barrier in moving it to the other cloud provider. It might not be possible without you doing that work. One of the other things is data gravity. Something I guess you still have if you're doing on-prem to cloud migration. If you're moving terabytes or petabytes of data, it isn't particularly fast to move that, but it also isn't free. There's often, I think all of the hyperscalers have this model. Ingress is free, so you can move data to AWS, and there's no charge to import that effectively. But if you want to move large-scale data sets out of AWS and onto another cloud, there's often egress costs there. So there is a cost to exit your data from the cloud provider, so that can often be a challenge. And then the last thing really is thinking about security re-architecture. So you've got role-based access, you've got IAM networking, and maybe some compliance controls, and they don't always map one to one to another cloud. So there might be a challenge in sort of thinking about how you address that. So those are the more technical challenges. And then let's have a look at some of the people and process challenges. Things we often see, team silos. So knowledge about how an application was built, how the architecture was put together, how the code works, what the rough edges are, might be stuck in an individual's head. They may no longer be with the business either. This application may just be running, and so moving it, you don't have that knowledge in the company anymore. So you have to rediscover that. Skills gaps. You might have a team that is very proficient in the cloud provider that you use today, and you're going to move to another one, and so they're going to have to relearn. They're going to have to learn some new skills, and so there might be some challenges in that. The other thing is change fatigue, and it's often one of these things that if it doesn't, maybe it doesn't create a barrier to a migration, but it slows it down. It's migrating a workload whilst also keeping up the BAU. Often organizations don't want to just stop moving forward. So applications are being developed, deployments are happening, and you're trying to migrate it at the same time. So that can often be a bit of a challenge. And sort of in the team as well, balancing those two things. You don't want to burn people out in having them try and do two jobs at the same time. And then the last thing is cut over risk. So although it's a technical thing, there's a lot of planning that goes involved in this. So working out when you're going to make that cutover, flip the switch and have traffic go from one cloud to another. There might be some integrations. Maybe you integrate with third parties, third-party APIs, and so you need to plan all that out and make sure that's all covered. And then some dependencies as well that may be technical or they might be process related. Um, and then the last section of challenges we'll look at, so commercial challenges. So one of the big things, paying twice. If you've done a migration before, let's say on-prem to cloud, often the data centers are sunk costs. That hardware's been purchased already. And so when you're moving a workload to a cloud, there's another kind of model of procurement you're factoring in. But if you're moving from one cloud to another, it looks a bit different. You're paying two cloud bills at the same time, and there will be a period when you've got the applications running in both clouds whilst you're testing and so on and waiting to do that cutover. So that can be a bit of a challenge. If you are moving to one of the big hyperscalers, there's often some funding programs and incentives to flatten, I guess, that curve and remove that barrier. AWS in the AWS world is called Migration Acceleration Program, aka MAP for short, and that can help offset like dual running and migration costs and so on. So if that is a barrier, speak to the cloud provider because often they can give you a discount or some credits towards your bill to take the sting out of that. And then the other thing to factor in is contractual lock-in. So, although cloud is all about pay as you go and use things on demand, you might have pricing agreements, you might have committed spend, you might have reserved instances, you might have compute savings plans, and so on. And these will effectively lock you in for a period of time. So, just check to make sure that those are not going to be a barrier. I've seen organizations moving from one cloud to another and they realize that they've reserved all of this infrastructure, all of these virtual machines for a year. And so then they have to delay that migration because there's no way of getting out of that. So it's worth checking to see what your reservations and commitments are and then factor that into the milestone planning. So, cover the challenges. Now let's have a look at some business drivers. So, why might you look at cloud to cloud? The first thing is commercial drivers. So you might have, and this is something we see a lot, lifted and shifted a workload from the data center to the cloud some years ago, and it hasn't been modernized. It's not cloud native, and in sort of looking at that modernization journey and what you might need to do to that application, often triggers a are we using the right cloud provider, and sort of looking at whether it's worth moving to another cloud at the same time as modernizing. So that's often something we see. Um, the next thing is growth drivers. And I've put this in here as genuine multi-provider need. Sometimes I've seen organizations think they need to go multi-provider, multi-cloud, and that's more of a sort of desire, maybe a sort of from the technical team, as in like, oh, we should be able to move this workload between cloud providers and have that agility. But there is a cost to that, almost like a tax to building an architecture and running infrastructure that can be easily moved from one cloud provider to another. So, if there is a genuine need, which could be regulatory, it could be for resilience requirements, anti-competition we see a lot. So certain frameworks and things you have to demonstrate that you can run across more than one cloud provider, or there might be a particular customer bias. So there's a very famous I don't know if I can mention the company, retailer that sees Amazon as a competitor. And if you're, let's say, a SaaS provider and you want to onboard them as a client, they'll ask what cloud provider you're using. If you say AWS, they'll be like, no thanks. We want you to run your software on another cloud. So you might have customers driving which clouds you run these workloads on. And so that might drive that multi cloud design. And then the other thing that I've seen quite a bit, especially over the last couple of years, is partnership relationship and with these cloud providers. So let's say you're an AWS technology partner and you're building software, SaaS software or ISV software, or let's say you're building agents and you want to do co-sell with a cloud provider and you want to say sell on the AWS marketplace, then it sort of makes sense and sort of reinforces and strengthens that partnership if you're building and operating those workloads on AWS. So you might start it off building on another cloud provider and then sort of pivot and move to a cloud provider by sort of way of a partnership. So that could be a driver there. The next thing is compliance drivers. So Let's say, for example, you've built a workload on DigitalOcean or a smaller cloud provider, and you want to run I don't know, a HIPAA workload. Actually, off the top of my head, DigitalOcean might be HIPAA compliant. I don't know, but I'm just using it as an example here. That might drive the need to then move that workload to another cloud provider so that you can benefit from the compliance and certifications that they have. AWS has 140 compliance certificates, Azure 100, and GCP's in third place. Can't remember the number off the top of my head, but that might drive the need to move from one cloud provider to another so that you can benefit from the infrastructure they've built that's compliant with it. And then the other thing is you might have outside of compliance, you might have an audit or maybe a client vendor assessment that drives reevaluation. So if you're building software, if you're selling a service into clients and they do a vendor assessment and they have a look at what you've built, it might be maybe that you need to move to, for want of a better word, a more grown-up cloud provider, and so moving off of, I don't know, something like Heroku onto AWS to build out an infrastructural capability that they're happy with. So that might be a driver. And then lastly, financial drivers. The first one is something that I actually see quite a lot. So accidental sprawl, or it might not be that accidental. Maybe this is through acquisition, but for whatever reason, you end up in a place where you've got all different applications or workloads spread across multiple clouds for no good reason at all, no strategic reason. And that creates all sorts of headaches, right? You've got to think about, people that you hire being proficient in all these different clouds. There's going to be knowledge siloed all over the place. Often, what I see is different levels of maturity in these clouds as well, and this could also build very powerful sort of financial driver for consolidating onto a single cloud and driving cloud to cloud migrations. One thing is purchasing power. So if you are going to consolidate onto a single cloud provider, there might be benefits there. You might be able to get some discounts and incentives from that cloud provider to do that consolidation. You can also unlock, if you're not aware, private pricing agreements. So if you spend more than $500,000 a year on AWS, you can take out a private pricing agreement with them, and that will give you discounts across services. So let's say you spend 250K on AWS and 250K on Azure. If you consolidate all of that onto a single cloud provider, you could benefit from some overall saving. It also makes things like centralized reservations for compute savings and commitments a lot easier as well because you're not having to do that across two clouds. So there could be really good sort of financial incentive for that. And then the other thing as well is lower total cost of ownership overall. There's a lot of foundational infrastructure you will need in a cloud environment, which Chris will talk about a little bit later, and you're replicating that across clouds and you're paying for that. So it just might be infrastructure that's effectively redundant and you can make some savings there. So challenges and drivers. What I'm going to talk about next is I'm just going to walk through a real world case study and example here and talk about some of the sort of challenges and drivers here to just hopefully get you to kind of crystallize the thinking here. So work with an organization, a technology provider called Streambased. If you're not familiar with them, their software platform is just about streaming data and processing things like real-time events and populating like data lakes and so on. And so they provide, I guess, this middleware for that. And when we initially engaged with them, they were hosted on GCP, and so they approached us. We had this conversation around. They built this platform. It was like an early release version. It was like a beta. They were now getting some traction in the market. They were onboarding all these customers, and they sort of got a bit of a stuck really. They were in a bit of a rut, and everything was manually provisioned on GCP. So onboarding these customers was very painful. It wasn't particularly robust. It wasn't scalable at all, and so that's the kind of background really. So we sat down with them and we talked about where they were at. What they ended up deciding doing was reviewing the cloud provider. Obviously, they could have put in some automations from infrastructure as code and made their life easier on GCP, but if they had to, reevaluate the architecture and look at it, what made sense for them and what made sense for the future. So first thing they did was they reviewed whether the current cloud provider was fit for purpose, and they decided that, well, it's on the next slide, so I'm not going to do a drum roll or anything, but rehost to AWS. And the reason for that was they were attracted to Bedrock as a platform for building AI agents. And so they were, it made sense for them to relocate their data to sit alongside the agents that they were building. And there was experience in the organization with AWS, and so they decided that it would be better to sort of rebuild bits of their architecture by using what they call best of breed building blocks. So using like Amazon's managed Kafka, EKS to actually I won't go into all the technical details. Chris will cover that. I'll spoil it, give you a spoiler there. And the other thing is, they were thinking ahead about partnerships, right? So they're a technology platform. They've built this technology platform. If they run it on AWS, then they could look at things like AWS partnership, AWS marketplace, and so on. So it opened the door for that, and so that drove that decision. With that, talking about the technical stuff, I think now's the perfect time for me to hand over to Chris, and he'll take you through what they did.
Cheers, Mike. Thank you very much. So, I'm going to talk a little bit about those steps that Mike outlined earlier on around how we see migrations going, and we're going to thread through that the kind of example of stream based. So you're assuming that you've decided that you're going to be migrating, whether that's cloud to cloud, whether that's on-prem to cloud, or whether you've decided that actually multi-cloud is the way forward. For that target environment, the place you have to start is capturing your requirements. So what does that look like? There are certain things that are going to be requirements as part of your migration that are going to decide what the shape of your ultimate environment looks like when you move to the cloud. These are things that you can't necessarily bolt on afterwards, but you have to be upfront making those decisions. So an obvious one, and one that Mike's touched on already, is the data residency and sovereignty question. So what jurisdictions can data live in, and increasingly which jurisdictions can may the operator be subject to? And that might influence kind of what you do in terms of your architecture, where you put in workloads within your cloud environment. There are going to be compliance frameworks, and Mike's already kind of mentioned a few that you might be subject to, and the deliverable it is really evidence and auditability of your environment, not just the controls that you might put in place to kind of service those compliance frameworks. And that's going to shape your logging. It's going to shape your account structure or your the way that you break out different workloads. So all that needs to be thought about before you even start putting pen to paper on what the architecture ultimately might be. In terms of recovery time objectives, recovery point objectives, what your availability needs to be like, those kinds of numbers are going to drive whether you are multi-region, whether you are single region, whether you are multi-cloud. Maybe that's why you have a driver to go multi-cloud. And all of those things are going to drive, again, the architecture and ultimately the cost of running these things in the cloud and kind of getting you to the end of that migration point. Mike's already mentioned egress exposure. So when you're going cloud to cloud as opposed to on-prem to cloud, that's where we have this big difference in migrations, in that you have a kind of one-off migration cost of getting terabytes, petabytes, however much data out of your current cloud provider and into your target landing zone. That might also be an ongoing cost potentially if you are multi-cloud and you're spanning different environments and you're needing to sync data across those. That's something that you're going to have to price in ahead of time. Mike's touched on vendor commitments. There may be existing credits. There might be enterprise discount agreements that have cliff edge dates, and that's going to influence planning and timing more than anything kind of technical that's going to come afterwards. In terms of Streambase as our example, one of the big drivers for Streambase was that they needed data residency for a growing client base, and they needed to have their workload running in different environments depending on where the clients were sited. So that was captured up front as a hard requirement, and that led directly to the multi-region, multi-environment design that they ended up with. One of the other issues that Streambase identified was the kind of operational readiness gap that they had. So the functionality they wanted in terms of their cloud provider was there in GCP. It wasn't a feature set that was necessarily the problem, but there was a big issue they had with operational readiness and being able to run confidently that workload within GCP. I know Mike spoke about some of the kind of best of breed that they were chasing, but kind of alongside that was this need to be able to repeatedly launch new environments to get to a point where they're comfortable kind of commercially launching the offering and running it with real clients in there. So thinking about their HA posture, the security readiness of the platform, the ability to repeatedly deploy and to do so in a timely manner. And that is another driver that we see for migrations. Not necessarily we want to move between cloud providers for the new feature set, but actually we can't do on our current platform what our customers need us to do. And so in that scenario, your migration isn't really just a migration, but it's more of an operational maturity project kind of wrapped up as a migration. And that's something that we often see with our customers, that it's kind of that operational readiness driver, not necessarily just a feature set driver. So when you are thinking about migrating and you're gathering those requirements, you also need to be gathering the inventory of what you're actually running today, wherever that is, whether that's on-prem, whether that's in a different cloud provider, whether you're going multi-cloud and you're wanting to replicate your environment across clouds. You need to know what workloads are there, what the data flows look like, where the dependencies are, and before you can move any of that's kind of the legwork that you need to have in place. And it's always more difficult than people are willing to admit. So there are ways you can, on different cloud providers, get that kind of information. So you can do simple things like GCP Resource Explorer, the AWS Resource Explorer, the Azure Resource Graph, and that will give you a list of what's deployed in your account, your project, or your subscription. So you can get that raw list of resources that you're running. You could even use your bills as a way to kind of indicate what services are in use, and then deep dive into those services to kind of do a deep inventory of what you've got. Hopefully, alongside that list of resources, you've also got some infrastructure diagrams, you've got maybe some infrastructure as code, you've got some documentation that sits around this list of resources so that you can understand the intent of what those resources are doing. Otherwise, you're into a phase of intent archaeology, as I've kind of coined it on here. So reconstructing not just what you're running, but the intent of those resources and what they are doing. Are they load bearing? Are they just there because they're scar tissue after somebody ran a demo and clicked up something and forgot to tear it down? Knowing what the intent of a particular resource is important, because that's going to drive the output, which is a migration backlog. So that needs to be a migration backlog, not just of things to move, but a sequence of how you're going to move those things. And the output that matters is one that you can then sequence in waves. So you understand who owns which resources, you understand where the dependencies are between resources. And it's not just a list or an architecture diagram, but it's something that you can use to actually build out your migration plan. And in our part 2 of this webinar series, we're going to be discussing some of the AI tools that you can use to accelerate that step and kind of make sense of a sprawling, undocumented estate, if that's the kind of situation you find yourself in. So, assuming that you've got your plan, you've got your migration backlog, you know what resources you're running, you've created a brand new GCP project or Azure subscription or AWS account, then what comes next? Well, landing zone deployment is what comes next. And this is some of the underlying required infrastructure that Mike was hinting at as he spoke a moment ago. So a landing zone is everything that needs to exist before you deploy any workload into your environment. And the reason for that is retrofitting it afterwards becomes a pain. Retrofitting it afterwards means re-platforming things that are already in production. It means rewiring data flows. And so the more work you can put into refining the landing zone ahead of time and understanding what your requirements are, what the resources are, where they're going to live in the new landing zone will pay dividends as you go forward. So that will help you determine account structures, how you're going to handle identities, the guardrails that you need within a landing zone, what the centralized logging might look like, what the network topology might look like. All of that is part of what we mean when we say what is a landing zone. And those foundations become tricky and expensive to retrofit, though, both in terms of effort, but also the cost of running them. And the reason for kind of getting that in place before deploying any real workloads to it is for that auditability and security side of things. So centralized logging is great, but it needs to be in place ahead of workloads going in. Otherwise, you're just going to be missing signals that are coming from the workloads that you're deploying into the environment. Account or subscription boundaries only limit blast radius if they're in there ahead of time and workloads are deployed into those different security boundaries rather than trying to be broken up and herded in afterwards. So the effort that goes in up front will put you in a much better position once you're actually operating workloads within the landing zone. So that rule of thumb is that nothing that's production shaped should ever land in an environment before the landing zone exists. It might feel slow up front, but as you go into that kind of operational phase, then it's going to pay for itself over and over again. So what did this look like for Streambase? What's the concrete version? So for Streambase, we deployed a foundational landing zone that was LZA, so the landing zone accelerator that AWS provide, driving Control Tower and the services within AWS that Control Tower wraps up. We use that to build out the foundation of things, and then we use Terraform to scaffold out the workloads. So we took the ClickOps GCP workload and replicated that in Terraform and deployed that to AWS. And that's a common pattern that we see with our clients, is that we go in, and actually the right fit is to use something like LZA and Control Tower for that code-driven config and that native AWS tooling to build out that foundational layer that's got that slow rate of change. And then once we start to deploy workloads with a customer, then it's all about that repeatability in Terraform and that kind of high rate of change and enabling DevOps teams, developers to build out those workloads in the environment. And it's important to note that LZA and Control Tower, that combination, give you a compliance-aligned set of capabilities. You have a low-code pipeline, a multi-account structure, centralized logging, KMS encryption strategy. You have drift detection against Control Tower. But that doesn't make you in and of itself compliant. The foundation is there and the tooling is there, but it's not an opinionated compliance product. And actually, as part of deploying LZA and landing zones with clients, we actually go through an exercise of figuring out what the base set of controls and compliance aims are with a customer so that we can start to implement those on top of LZA and Control Tower using that low-code pipeline. We did this with Streambase specifically because they describe themselves as newcomers to AWS, and so the point of the accelerator was exactly that. It was to get them into a good foundational position as quickly as possible, and then we could start to move on to kind of from the boring basics, the necessary bits of the foundations, to actually getting them to a place where they can deploy workloads and service their clients. When it comes to different cloud providers, and no matter which direction you're migrating, whether you're going on-prem to cloud to cloud, whether you're multi-cloud, each destination has an opinionated landing zone approach. And I've just got the kind of big three hyperscalers there. So AWS, we've already mentioned Control Tower, landing zone accelerator, and then customizations to that using CloudFormation and CDK are typically what we would suggest to customers that are kind of asking us to help build out a brand new landing zone on Migrate or whatever it might be. Azure and their cloud adoption framework, they have an Azure landing zone IAC and portal accelerator that will allow you to stand up a kind of an opinionated basic environment quite quickly within Azure. And then you can use the Azure verified modules of Terraform or Bicep, depending on what your particular poison is, to actually customize that environment ready to receive workloads. And in GCP, you have landing zone design guidance and blueprints to kind of build that cloud foundation. And that they have various different bits of guidance around what identity should look like, what resource hierarchies should look like, and how networking and security should be layered in onto those. And really, the reason I kind of blast through those very quickly on a slide here is that the multi-cloud takeaway, or the cloud-to-cloud takeaway, is you build your landing zone once per provider, and each of those landing zones will be idiomatic in some way to that particular provider. So the account, the subscription, the project models and policy engines all differ enough that actually having a single abstraction over all of them may well cost you more than it saves. So the advice is consistency of principles when you're deploying landing zone multi-cloud. So centralized login, least privilege, infrastructure as code, all that kind of good foundational stuff. But don't necessarily implement it exactly the same way across your different cloud providers for each different landing zone. So you have your landing zone deployed. The boring bit is over, and it's time to deploy the bits and pieces that are going to be actually making the company money. So we start to think about the differentiated stuff that's actually going to be running in the landing zone. The landing zone is really the kind of the gate. And once Stream-based had got through that gate and we'd built out that environment, then everything they were looking for kind of downstream got cheaper in terms of time and effort. So the multi-region, multi-environment deployment and automated provision of new environments, rapid but safe production deployments, a security posture that they can actually put in front of clients, all of that became possible. And those foundations were there and ready to go for a workload to go into. So what does platforming an application look like, and what does it look like to be portable between clouds? In terms of stream-based, Mike's already touched on this a little bit. The migration was actually relatively simple. So the workload today runs on Amazon EKS, which was almost a direct translation of what they'd done in GKS. The difference here was that we actually worked with them and made the decision to run EKS in auto mode. And again, this was about the operation of the workload. The Stream-based team weren't necessarily interested in managing Kubernetes up and down the stack. And so using auto mode and kind of bringing that efficiency of operation brought them a lot of confidence. So if you're not familiar with EKS auto mode, essentially it's AWS managing your Kubernetes nodes for you. So they're managing the lifecycle of those nodes, and it's kind of Karbiter-based auto scaling. There are AMIs that are running there, and AWS framed this as a movement of the shared responsibility line. So a chunk of what was the customer's responsibility in running the Kubernetes cluster becomes AWS's problem. There are caveats there. You give away some of the control that you might have, but for Stream-based, it was certainly worth it in terms of operations. They were a small team, relatively new to AWS, and migrating because they had that operational readiness gap. Likewise with Aurora, essentially paying AWS for the ops capacity that Stream-based didn't have. We also made some other operational improvements as we went along. Mike mentioned that Stream-based had a ClickOps beta environment, and so we took those that rough architecture, and we defined it in Terraform. So that the environment turned from the kind of ill-defined blob to actually something that was auditable and traceable, and you could put into version control and actually see how it changes over time. It also gave them that redeployability and the fact that they could then deploy to different regions for different customer requirements. Alongside that, we built out CI/CD pipelines for them. So GitHub Actions, because they were already in the GitHub world. So it was a single place for both their code, for the application, for the infrastructure, and the pipeline itself. And the point really with Stream-based was that this kind of migration, a lot of the cost was in the planning and in the foundations. It wasn't necessarily in the application. In their particular case, because they were already in Kubernetes, already had containerized applications, the app migration had a natural path, and it was actually relatively lightweight. If you're in that situation, great. You don't need to necessarily overestimate the effort of doing that application migration. However, if you're not in that position, conversely, migrating can be, as Mike kind of hinted at earlier on, much more of a challenge. And so, what is the reality of kind of true portability between different cloud providers? What genuinely travels between clouds are things like your container images, right? The workflows that you have for Terraform, not the kind of specifics of the code, the providers all differ, but those workloads, they're portable. The CI/CD patterns themselves are portable. Your team's operational habits and the way they work. The things that don't move are the kind of things Mike was highlighting earlier on, things where you've bought deeply into the provider's ecosystem. So app functions, Lambda, managed databases, IAM models, networking constructs, all the things that are provider native services that you adopted, probably with very good reason. Maybe it is to reduce operational overhead, maybe it's because of other benefits they buy you, but you adopted it because it was good. And kind of we all intuitively understand that those things are not going to be necessarily as portable across cloud. So portability then is really a spectrum, and you buy positions on that spectrum by giving other things up. So if you want to be super portable, so you're right at one end of the spectrum, then the kind of things you have to give up are those managed services, and you have to take responsibility for more of the care and feeding of things yourself. So you might go for lowest common denominator services like EKS, GKS, but you are building in an operational overhead then. So that's kind of a real cost that you pay in running the workload and building the workload against potentially, well, against the cost that you may never, against a benefit that you may never realize if you never have to be portable between clouds. So on that spectrum, most people probably shouldn't be buying much of that portability unless there are specific reasons for doing it, right? Maybe you have to prove to stakeholders, to shareholders that you are exit ready from a particular cloud provider. Maybe maybe it's regulatory, maybe it's customer, I don't know, but they want proof that you can leave that particular platform. Then spending that money in terms of operational effort and development effort to be portable makes sense. You can design for that particular requirement. You might just need a documented exit plan, though. Is it enough to not necessarily have real technical ability to switch providers tomorrow, but do you have a documented exit plan that says, should we need to, this is how we would do it? And that could be simple things like ensuring that you have the understanding of how your workload hangs together at a logical level, and you have a reasonable grasp of what changing your IAC might look like. There are no undocumented changes in your environment in terms of things done manually and through the console. That kind of approach to this exit readiness question is a lot cheaper than having truly portable workloads. And it's often what the real requirement is rather than true portability. On the portability point, it's something that we've kind of touched on already. When you're migrating, data center to cloud, cloud to cloud. When you're switching between different cloud providers, stateless compute is the easiest thing to handle, right? You can build out something in a new place and cut over to it when you're ready. Stateful services, anything that's got data involved, is the harder problem. We already talked about kind of egress costs in terms of extracting data from environments, egress costs in terms of continuous replication to kind of maintain the ability to service clients while you're doing your cutover. All of that is part of that kind of data portability problem, which is really the hardest part of the portability question. That egress pricing, cloud providers have made commitments around waiving data egress fees in certain circumstances. So it's worth, if you are in that situation, it's going to be a one-off thing. Look and see if you can get provider credits and figuring out exactly what situation you're in, rather than assuming anything, because T's and C's do apply. But there has been some movement by the cloud providers kind of on that front. In terms of migration and kind of migrating data and ensuring portability, when you're planning a migration or you're planning out a multi-cloud strategy, plan the data last. It's the piece that relies on everything else, but make sure that you're rehearsing it first, because that kind of cutover of stateful data is going to be where the dragons really live. So do make sure, as you're planning things out, that is part of the plan to rehearse any moves that you need to make. So, on to operations and observability then, and I'll go back to the slide I was on a second ago. There are kind of some simple answers here, or at least kind of defaults. So if you are just migrating cloud to cloud, or you've gone on-prem to cloud, you're in a single cloud provider for most of your work, use the native tooling. Each provider has tooling for security and compliance. And if you're landing in one cloud, using that native observability stack is the default and probably most cost-effective answer. It's integrated, it's already within your compliance boundary, it's one less vendor to manage. Unless you have very specific requirements, it's likely that native observability is going to cover 80-90% of what you need to do, and it might not be worth investing the time, effort, and money in that kind of last 10 to 15%. And that was the situation that Streambase were in. Streambase setup, we used native tooling within AWS when we moved them. So it was container insights and pulling workload metrics from EKS. We used BotCube to pipe cluster events directly into Slack, because that's where the small team lived. So having that kind of coming up in their working environment made perfect sense. The use of GitHub Actions and kind of the visibility that gave them meant that for pipeline deployments and things like that, they were looking in the same place that they were already looking at their code for infrastructure and application. So again, it kind of made sense for them to continue to use that rather than bringing in any other tooling. The simple principle really is that, I guess, the observability tooling should be reducing the number of places an engineer has to look to find a thing, not necessarily adding another one. So whatever you decide in terms of single cloud, whether you're using native tooling or not, look to reduce the number of views of the environment that you have. In terms of multi-cloud, then you have a choice. Do you have one pane or three? Do you go and use native tooling per environment because it's the cheapest and probably has the deepest integration, or do you go third-party SaaS? Do you go for a Datadog, a Grafana Cloud, and the kind of that whole ecosystem? It's giving you one view across all the providers. Yes, you're bringing on another vendor. Yes, there's another bill, but that does give you that single pane of glass for security, for compliance, and just for kind of tracing generally. And if you have to kind of provide that kind of evidence in any way, shape, or form across clouds, then having that third party involved makes sense, rather than trying to stitch together various different bits of information from different cloud providers into one cohesive story every time that you need to do get involved in an audit cycle. And finally, day two, DevOps. Migration doesn't end at the cutover. So you've migrated, well, you've done your due diligence, you've understood exactly what the business drivers are, you've understood what you need to move, you've planned it out, you've built your landing zone, you've migrated workloads, you've got great visibility of what's going on in the environment. But day two is where you're going to realize all the benefits of doing a migration. So for stream based, what they were able to realize was that highly available infrastructure across multiple regions. They had an enhanced security posture that they could put in front of customers and then they knew would be robust and stand up. They had automated, repeatable, regular production deployment that they didn't have before, and they built out a foundation that was ready for kind of the day three, if you like, where they were looking at leveraging Gen AI features in Bedrock. So the message here is really, once you have done the work of migration, that's the stable foundation, and then start to look to refactor and continue to unlock benefits within the cloud provider of choice. And that might be, if you are on that the lower end of the portability spectrum, that might be bringing in more and more managed services to realize kind of operational benefits. It just depends on exactly what your workload and your requirements look like. The key thing I would mention is when we were working with Stream-based, we were careful that we brought the Stream-based team along with us. They were a team that were not native to AWS. They'd been working in GCP. And so it was key for them to be able to understand and extend their environment. And that's really the standard. It's no good bringing in a partner to help with migration and the partner leaving and being the only people with knowledge of the platform. That's just a liability. So understanding and being able to extend what's been built before is and has to be the standard for any migration to really realize the real benefits. So I am going to hand over back to Mike.
Thanks, Chris. That was super useful. As a huge amount to cover there. There's a lot to consider. Like on the surface, you think cloud to cloud migration is is going to be easy, straightforward. Just copy paste these workloads. You've got some Terraform already, maybe. Let's just point it at a different provider. Away you go. And there's lots of things you need to think about. I've got some key takeaways that I'll run through. But one of the things that you mentioned that I'm always forget and I'm reminded of is you've got these egress fees for effectively extracting data from a cloud provider to then move it elsewhere. And it is worth speaking to your account manager or your rep at the provider to see if you can get those waived or discounts or something there, because it can often be, especially if you've got petabytes of data that you've gathered over the years, then it could be worth looking at sort of trying to extract that, or speaking to your new cloud provider and say, look, we've got all this archive data, we're just going to leave it there. Is there anything you can do to take the sting out of us moving it across? And they'll probably be able to throw some sort of incentive or discount to. Obviously, they can't pay for the egress costs, they can't give money to the other provider, but they might be able to discount something. Anyway. So three key takeaways here. First thing is going all the way back to the start, thinking about the drivers. There are lots of different ways of doing this, and it kind of links to the last driver about portability versus overhead. But if you know exactly what your drivers are, why are you doing this, why are you moving, then that can factor into your decision, but also your planning. Like if you're moving a workload from one cloud provider to another, and previously it was lifted and shifted, or maybe it was built 10 years ago, it could be the perfect opportunity to bring in a modernization work stream and say, oh, maybe we can put this in containers, or oh, maybe we can, use a more managed database. We're using Microsoft SQL Server. If we on Azure, if we move to AWS, we could move to Aurora Postgres, and then you can save yourself some licensing fees and stuff like that. So, starting with the sort of drivers, really. Then having thinking about the foundations. So in a new cloud, as Chris said, it can be quite expensive to retrofit. So putting in a landing zone first, and then sort of building from there, setting up your hosting environment, and then the last thing, portability versus overhead. There's a trade-off there. It's effectively a tax if you want it super portable. So don't, my advice is don't do it unless you need it.
Mm.
Um, just before we wrap up, a few things I want to cover. So first thing is next week we've got AI acceleration using AI to help accelerate migrations, but also making the best use of AI in the cloud once you're there. QR code on screen, scan it. You can sign up if you haven't already. There'll be a link in the email after this as well. A few things that we can help you with. So if any of this resonates with you that we talked about today, migration discovery and planning. If you're curious about what co-investment you can get from AWS from the migration acceleration program, whether that be service credits or money towards professional services, do have a chat with us. We can take you through that. If you're thinking about foundations in a new cloud, so landing zone advice, questions about data sovereignty, compliance, security, and so on, we can help with that. Again, app portability and modernization. Does your app need to be super portable across clouds? Are you thinking about modernizing your application as you move it and getting that right? And then the last thing really is single versus multi-cloud strategy. We talk a lot about this with clients, so do feel free to reach out to us if you want some advice and help thinking about that. Don't think we have any time for questions. We've run out of time, but I guess one very, very quick one, Chris, that I had, and that's Steam-based going multi-region in AWS. Obviously, data sovereignty was a key part of that. So you're running across multiple clouds, multiple regions. How could they be sure that they were storing the right data in the right region?
Mm. Yeah, so this comes back to gathering those requirements ahead of time before we start building anything out. So then in your cloud provider of choice in the landing zone, it's about getting those right controls in place for particular account subscriptions projects. So making sure that, in an AWS world, for example, you might be using SCPs to say, right, this account is our account for this region, and we're gonna deny anybody building anything out, dropping anything in a region that's not what it's intended for, and you can replicate that paradigm across kind of GCP and Azure. But you can using the tooling within the landing zone and the various different iterations, you can enforce that should you wish to, or at least report on it and have the kind of compliance notifications when somebody does something that they ought not to be doing.
Yeah, yeah. Okay, cool. Brilliant. I did have one more question for you, but we're out of time. So thanks, Chris, for sharing your insights there and taking us through the case study example. And thank you everybody for attending. And hopefully we'll see you on the AI acceleration one next week.